Hi, I'm Calvin,
And I'm Matthew.
and we're going to teach you about logic circuit analysis, okay? So when you have a logic circuit like this, the very first step to find your logic expression is to find the test points, okay? So if you look here, we put test points after each one of the logic gates, so that we can find the new expression being portrayed through the gates. So if you look at this big graph, the next step is to make a table. Okay? So we went over our truth tables, and your very first truth table, we did a 2x2, a 2x4.
I'm telling Mr. Vincent about.
Now we're doing 3 inputs, and we're going to 8.
Mr. Vincent.
So we start out with 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, etc. until we have all these points covered. Next, we find the test points. See, each one of these are the 5 test points that I previously talked about. Okay? So, we can get rid of that because we have the same thing except bigger version right here.
Whoa!
So if you see each test point, you're going to want to fill out what happens when each of them are pressed in. So we're going to start with x. When x is 0, the first test point is 1. Okay? So this x, see how it's an x naught starting from here since it's 0? This is an inverter, so it gets changed to x. Okay? And then we're going to do test point 2. When y is 0, our second test point, which is right here, is also 0 because you need a 1, 1 to continue, not a 0. And now we do this for each test points until we have a full chart that looks exactly like this. Alright? Our next step is to work from the inputs to the outputs. This is the trickiest part, okay? Because you need to take your test points and you need to follow them to see what actually outputs a 1 at the final. Okay? So when you start out, you have to get past the first IC, right? So the first one, to get a 1 input, you need x as 0. So x naught, right? To get past this one, you need x naught and y to get 1, right? So this is x naught y. And then to get past this gate, you need an x naught y and z to equal 1. And then this is an OR gate, so if this equals 1, then this will equal 1. So your first point is x naught y z. Alright? Next point. We're going to go through here.
So Andrew,
So
tell us what's
this gate,
going on over here.
you need z,
No.
right? Z and 0 y. Correct? So not y and z.
Alright, as long as
So
we
this
get
is
it good.
not y and z. And then this,
Don't worry,
that's
I
just
think
an
you're
automatic way. That you automatically
seriously.
get a 1 right here.
5,
So that's this point right here.
3,
Alright?
2, 1, starting.
Finally,
So Andrew,
you need
tell us what's going on over here with
Your
our universal
X,
gates. And
not y and not z. Because when this equals 1, this gets turned to 0. When this equals 0 as well, this outputs a 1. And when this outputs a 1, that outputs a 1 as well. And then it's an OR and you get 1. Your next step is for each point that you found, this x, y, z, x, y, z, x, y, is to put them into your graph. So it'll be 0, 0,
take
0,
5. Andrew, so
and see how it's 0, 1, 1?
same
That matches up.
gates that you've been
1.
drawing for 5 minutes now.
The next one
What's going
is
on
1,
here?
0, 0. That matches up. 1.
See how you lose a dojo point?
And then your next one is 1, 0, 1.
Alright, step 1, you get an eraser.
Matches up and 0.
I'm going to beat you.
And then 0, 0. So now you have your full table done.
Different eraser.
And next you can take this table, bring it all the way around, and then find your logic expression right here. And that's how you analyze a circuit.